In this video, I'll be adding procedural level generation to the simple platformer I made in part 1. If you haven't watched part 1 already, I recommend doing that first. However, if you watched the original upload, I want to make an important correction. When I said objects in Godot were reference counted, this was mostly not true. I was mistaken. Just removing the level from the node hierarchy is not enough to properly get rid of it. Instead, I recommend using queue-free. You can create classes that are reference counted by extending reference, and some built-in classes do this, but nodes don't. Big thanks to Ulti Durkinson for pointing this out in the comments on the original upload. I also got a good tip from Captain Bayhab in the comments. In many cases, it's better to use a camera 2D node rather than shifting the level around. To recreate the behavior I had before, I'll add the camera 2D node as a child of the player, then shift it up a bit so it follows you around but you still see more above than below. And don't forget to set it as the current camera. Then I need to set limits so it doesn't show below the ground or off to either side. I could do that here in the node inspector, but I'd rather do it in code so I don't have to manually edit it if things change later on. I'm going to need the tile size a bunch in this tutorial, so I'll go ahead and put that in a constant. I don't want the camera to show anything left of 0x, right of the window width, or below the bottom of the ground. I'll also delete the original code that moved the level around. And now that I'm using the ground's position, I really need to align the parent node with the child nodes. However, if we test this, we'll see there's still a problem. The win and lose screens don't position correctly anymore. To keep them at a fixed location on the screen regardless of where the camera is, we can move them inside a canvas layer. Now we just need to update the node paths in code. Now let's move on to level generation. For most of the coding, I'll be using a third-party code editor on the side because I wrote a plugin to cheat so that you don't see me making typos and I don't have to edit them out. Level generation is going to get pretty complicated, so I want to put it in its own script file. You can create one without attaching it to a node using File, New Script. I'll call it Level Builder. As with my previous video, I'm not going to try to teach beginner programming here. This is really aimed at people who already know some programming but are new to Godot. I'm going to plan out the level as a matrix of tiles essentially, represented by an array of arrays. I'll define the width and height as constants for now, and I'll call my outer array map. Now because the script isn't attached to a node, the ready function won't ever get called. Instead I'll use init, again with an underscore. This acts as a constructor, called when you create a new instance. Here I'll fill in my array of arrays. Now for each tile in this map I'll need a few pieces of information, so I'm going to define a new class to group that information together, and come back to this. Each script file is its own class already, but you can nest classes inside a class. First, for tiles that contain a platform, I need to know how long the platform has to stay in place before it falls to make the level winnable. For tiles that don't contain a platform, I'll leave this unset. Secondly, I'll need to know which tiles must remain open for the player to move through them, or more specifically, what time range they need to remain open. These will remain null for tiles that the player doesn't need to pass through to beat the level. So now let's go back and instantiate this for each tile. Before we dive into the complex stuff, let's try just placing platforms totally at random so we can start to see something happening. I'll put this in a function called generate. And now we need to actually use this script. Over in the level script, I'll load the level builder script into a constant. You can do this for scripts just like with scenes. Then I'll create an instance and call generate. But then we need to translate all those tile infos into real objects. First, I need to load the platform scene into a constant so I can instantiate it from code. Then going through one tile at a time, I'll check if platform until is set. And if it is, I'll create a new instance of that platform scene, and set its position and time until fall, and add it as a child node to the level. Now let's delete the platforms I placed manually and see how this looks. Okay, we've generated a level of sorts, but things aren't aligned quite right, and who knows if it's actually winnable. Let's do a bit more setup before we get to the hard part. Generating winnable levels took me a lot of experimentation and debugging to get right. I'm not going to go through all of my mistakes one by one, but instead I'll show you how I was able to finally make sense of things to get it right. In short, visualizations. First I'm going to create a grid of squares the size of my tiles. For that I'll use a texture rect. I've created a square image I'll use to outline the tiles. Multiplying the tile size by the level size, this needs to be 640 by 1600. And I'll set the stretch mode to tile so the squares repeat to fill the area. I'll position this to be horizontally in the center and move the ground and player down. I'm also going to move that tile size constant into the level builder because it'll be used a lot more there, and I'll make a constant for half the tile size. Back in the level script, I'll update to point at the constant in the builder. By having it in just one place instead of a copy in each script, it'll be a lot easier to update if I change the size later. Let's also offset the platforms we create by the X position of that background grid, so all platforms are within its bounds. To avoid looking up that object every time, I'll get this position once up front. The onReady keyword just means it waits until this node and its children are added to the scene tree, basically the same thing as setting it inside the ready function. And also because the center of the tile platform scene is the center of the sprite, let's offset by half the tile size. And now let's see how that looks. The level complete is getting triggered here because the platform is touching the goal now, but we can fix that later. Meanwhile, I want more than just a grid to help me debug. I also want to see which tiles I've marked to be platforms and which tiles I've marked to keep clear. For that, I'm going to use a tile map. I'm calling this debug visualizer. I need to set its tile dimensions to match what I'm using, and position it to line up with that grid. Now let's edit the tile set. First I'll add a platform tile. It'll be easier to set these in the tile map than creating instances of the actual platform scene. Now this part can be a bit confusing at first. It's designed to make multiple tiles out of a single image, but that's not how I'm using it. When I click New Single Tile, I'll have to drag a box to cover the image. I might as well also add a collision box to this so I can test out the jumps without using the real platforms. The only reason I'm not using this for the real level is I can't make these tiles fall down. Next, let's add a tile for the spaces that need to remain clear. I've created an X sprite for this. Once again, I'll create a new single tile and select the region, but I don't need to add a collision box this time. Just to check that this works, let's comment out the code that creates the platforms. Then I'll pass the tile map as a parameter to the level builder's constructor. Then over in the level builder script, let's save this to a variable. And I'll define an enum for the visualization tile indexes. The first tile is the platform and the second is the spaces that need to be clear. Now I can refer to these by name to make it easier to follow. And then we can set cells within this visualization tile map as we generate the level. And now this should look exactly the same as it did when I was instancing the platform scene. But in order to really make this useful, I want to watch the level build step by step. For that, I'll add a button to the canvas layer. I'll resize it a bit and attach a script. For now, I'll comment out that generate call in the level and create a new function in the level builder called next step. There, I'll add just one random platform at a time for now. Then I'll move the level builder to a member variable on level so I can access it from elsewhere, and I need to make this on ready so that debug visualizer exists when it's passed in. Lastly, I'll need to access this from the button script and call next step. Now let's test it out. Some of them will be off screen, but with a few clicks we can see it's working. There's one other kind of visualization I want to do though. I want to show the path the player is intended to take through the level. For that, I'll make an array of points in the level builder. To test things out, I'll add these points based on the random tiles for now. Then over in the level, I'll draw lines between these points. For that, I'll need to implement the draw function, again with an underscore because it's something special called by Godot. We can't draw a line with less than 2 points, and as we go through them, I'll save the previous point so I can draw a line between that and the next. And I'll offset all of these like I did with the platform, so everything's on top of that grid background. There are a couple more things we need to do for this to show up. First, draw doesn't get called every frame unless we call update, so I'll do that in process. And lastly, I'll need to change that tower background to draw behind its parent so it won't cover up the lines. Now if we test it out, we can see the lines are being drawn. So now it's time to dive into procedural generation for real. First, the level builder script is going to need a little more information. Specifically, it needs to know the jump velocity, move speed of the player, and acceleration due to gravity. So I'll go back to the player script and make these constants. Then I'll load the player script into another constant in the level builder so I can access them. Next, there's some state I'll need to remember between steps of level generation. For a quick recap, the plan here is to plan out the player's path through the level first. As we go, we'll track which tiles need platforms and which tiles need to be clear while the player passes through them. Because this is all time sensitive, we'll need to keep track of not only where the player is at each step, but how much time should have elapsed. To allow for a margin of error, I'll use both a minimum and maximum time. The soonest time we can expect the player to be there, and the latest time we can guarantee it's safe for the player to be there. I'll also go ahead and define that margin of error as a constant. I also want to prevent generating a path where you walk back and forth, so after each walk segment I'll force a jump. Similarly, I don't want the path to keep hopping between platforms at the same height, so after each same level hop I'll force an upward jump, and I'll just reorganize these a bit. I'm going to set all these variables in a function I'm calling reset, because I'm honestly not sure yet if it's possible to paint ourselves into a corner where we can't build a winnable level anymore. So I'm going to plan ahead to be able to start over and try again if that happens. I'll start the path at the bottom left of the level, and I'll implement this tile to pixel helper function in a moment. I'll set the times at 1 second so there's already some margin of error, and it'll also force the first jump to be upward because there can't be a gap to jump over at ground level. And lastly, I'll clear the visualizations. Tile to pixel is really simple, just a multiplication. And we should call this at the start too, just to set everything initially. Now let's go back to that next step function. First, I need to choose whether the next step is a walk or a jump. If we're not forcing a jump, I'll pick at random. Jumping is also where we'll see if we got stuck, so I'll call the jump function try_add_jump, and it will return true or false. If it returns false, that means we failed and need to reset. Simple enough so far, but now we need to actually implement adding a jump or walk to the path. Let's do walking first because it's simpler. First we need to find out what tile the player is at. I'll make a helper function for that in a minute. Then let's see how far left the player could go. I'll check tiles one by one, starting from the start tile. Note that when using a range, the end is not inclusive, meaning that when we're counting backward, the last tile x value will be 0 here. It won't actually include -1. Now how do I know if this is a valid tile to walk to? Time for another helper function, and again I'll come back to that in a minute. I find it helpful to write code from higher level concepts first, and then fill in the details later. So if it is valid, we'll update the minimum tile x, but otherwise stop checking. If there's an obstacle, we can't walk past it. And then I'll do the same thing basically for moving right. Now that we have a valid range, we just have to pick a destination. This could be done with rand I and a bit of math, but I figured it will be easier to read if I use rand range and just round to an integer. To calculate travel time, I'll need to know the exact pixel position. Time for another helper function. And the distance gets divided by move speed to get time. Then let's figure out the maximum safe time for the player to be finishing this move based on that margin of error. Next I need to mark all the tiles the player will pass through. In order to loop through those tiles, I'll need a direction, whether we're counting up or down. I want to include final tile x, so I'll need to add or subtract one accordingly to compensate for the end of the range not being inclusive. Then at each step I'll get the pixel position, and I'll use another helper function to find all the tiles the player will touch at this position. I could do all this based on tile coordinates, but I'm doing it based on pixels because I want to reuse the same code when I do jumping later on. The positions the player passes through in midair won't align so nicely to tiles. And then I should also add the platform to walk on. Then yet another helper function for marking those tiles we gathered. Then let's add points for the path visualization. And then I just need to update a few things. The time the player is expected to finish this move, the final position, and I want to force the next move to be a jump. Now all that's left for walking is to fill in those helper functions. Pixel to tile is pretty simple, just dividing by tile size and rounding down. Valid stand position is pretty simple too. Let's reject anything above the level. Then, if we're not at the very bottom, let's check if there's already a platform underneath. If there is, we've already been there, and I don't want to backtrack. Then we just need to make sure both tiles the player would occupy aren't blocked, which I'll make another helper function for, and that the tile beneath can have a platform added. Another helper function. Those will be really quick. For isOpen, I'll just look up the tile and it's open if either platform until hasn't been set, or if the platform would have fallen by this time. For can be platform, really I'll lie a little bit and say that it can be a platform if it's inside the ground, just to make the rest of the code simpler. We won't really put a platform in the ground, although we could. Otherwise we can put platforms as long as we haven't already marked it to be unblocked. I'm not bothering to check when it's unblocked because we don't add any new platforms after the level starts, and unblocked start time won't be in the future because we haven't planned the future yet. Okay, next on the helper function list is tile x to player center, also very simple. I'm doing all these coordinates based on the top left of the tile. I'm not sure if there's a good reason for this, but honestly I just don't want to go back and change everything to do it differently. And now we move on to get touched tiles. To be sure I get everything when we deal with jumps later on, I'm going to check all 4 corners and the left and right center. Then I'm just converting these from pixel coordinates to tiles. There are probably more efficient ways to do this, but in the end the entire level generation takes less than a second, so it wouldn't make a noticeable difference. Just 2 more helper functions to go for walking. Set platform until needs to skip tiles that would be inside the ground. Then I just look up the tile, set how long it needs to remain a platform, and mark it on my visualization. For unblocked tiles, I'll go through the list, skip anything that's outside the level, then look up the tile. We might pass through the same tile twice with jumps, so if the unblocked fields are already set, I'll just extend the end time. Otherwise, I need to set both fields and show it in the visualizer. Now at this point, if we just make a dummy function for try_add_jump, we can at least see the first walk step and make sure it's working. Perfect, that's just what I wanted. But now let's get to the hard part, jumping. For this I'm going to add a couple of variables. First, as we're tracing the path of the player jumping, I want to use the same interval that Godot runs its physics simulation at, so I'm going to save that up front. Secondly, I want to pre-calculate the air time for each difference in height that we could land. I'll calculate these once up front in init. This is where I made a mistake that stumped me for a while. I made an error in this formula, and all the error times seemed plausible, but they weren't quite right. This is why I started drawing lines to trace the movement path, so I could see when the arc of the jump matched what actually happened when the player jumps. You might notice, since the range end is not inclusive, I'm only doing this for jumps of up to 4 tiles above. That's because I've observed that the player can't quite reach a platform that's 5 tiles higher. Okay, so now we finally move on to try add jump. However, almost immediately I'm going to split off part of this into a helper function. Figuring out where to jump is going to take some work, and then acting on it will take some work. If we can't find a valid place to land, we'll just return false. But this time, I'm going to switch over and write that helper function before going any further. First, let's decide the range of heights we could land on. We already know it can't be any higher than 4 tiles above, and the lowest tile we'll allow depends on whether or not we've set force up. And now I'm going to build a collection of possible ending spots. For each tile, I'll check the amount of time we'll be in the air. Then I can calculate how far we can move horizontally in that time. Then I'll determine the minimum and maximum tile x coordinates, taking into account the bounds of the level. Finally, for every tile in that range, I won't allow jumping straight up, so we'll skip that. But otherwise, if it's a valid standing position, I'll add it to the list. If that list is empty at the end, return false, otherwise we'll pick a tile at random from the list. Now back to try add jump. Let's figure out the direction of the jump first. Then the duration. Then how much time it'll take for the horizontal movement. Then the y-coordinate in pixels for our ending point. Then we need some simulated state as we step through the motion, a position, a velocity, and how much time has elapsed. And lastly, we'll be building up a list of tiles we touch as we go. We'll reach the target height at 2 points in the arc of the jump, so we should continue as long as we're either above it or still moving upward. Luckily, we already have a function for figuring out which tiles are touched at each position. I'm doing this before the motion because the last iteration of this loop will actually put the intermediate position past our stopping point. I'll also add to the path visualization. Now it's time to start applying motion, acceleration due to gravity, movement based on current velocity, and updating the elapsed time. Now, a real player jumping could do a lot of things with their horizontal movement. They could jump straight up at first and then move sideways as they fall. They could move back and forth in the air. Lots of possibilities. I originally planned to cover a few variations of this, but there were some complications. Specifically, the jump arc might intersect the platform you're going to land on. The easiest way to avoid this is just to always do the X movement at the end of the jump. So we'll only start moving horizontally when the elapsed time reaches a certain point, the point when there's only as much time left as we need to complete the motion. Then it's just a simple matter of moving in the right direction at the player move speed. Now we're done tracking the motion, but before we start marking those tiles, let's figure out the maximum ending time for this jump. Then luckily we already have a handy function for marking them. And then we need to add a platform where you land. Then again we need to update a few variables, the times, the player position, don't force a jump on the next move, and only force a jump up if we didn't jump up to a higher platform this time. Finally, return true. That's it, so let's test it out. As I click the button, we keep extending the path, and I can follow along to see the rest of the level. Now you can see the path planned isn't the optimal path, but the point is we can now generate levels that are guaranteed to be traversable. Let's finish up just a few things here. First, let's make that level generate function just keep calling next step until it reaches the top of the level, and then uncomment where we called it from the level script. And another quick test. Uh-oh, it gets stuck in an infinite loop, because when it gets to the top there aren't any valid jumps. It thinks it got stuck and is resetting. Let's just change that so it ends the level when there aren't any valid jumps instead of resetting. And now we have a fully generated level without clicking a bunch of times. But this is still the tile map visualization we're jumping on. So let's comment out those set cell calls and uncomment the part where we create the real platforms. Also, that goal was still the one we placed manually, so to place it from code we'll have to split it off into its own scene, and then let's delete the original one from the level. Now we can load it into a constant. And then let's put it at the final player position from the level generator. I'm using the same offsetting I did for platforms because the center of the scene is again the center of the sprite, and the level is shifted over from the left of the screen. Okay, let's try it out. It looks like the goal is triggering early by touching a platform again, so let's fix that with collision masks and layers. There, now it's working. And because we're using the real platforms, they're falling behind me if I don't get too far ahead. There's just one piece I want to add now. The original idea was to have falling platforms be a hazard, but right now the only platforms that fall are the ones behind you. So I'll add more falling platforms to the empty spaces. I'm going to implement this in a really lazy brute force way, because again, it's going to be fast enough. For each row, I'm figuring out how long it would take a platform to fall from that height. Then for each tile, if it's neither occupied nor needs to be unblocked, I'll give it a 1 in 10 chance to try adding a falling platform there. Then I'll just pick a random fall time. Check if any of the tiles below need to be unblocked during its fall, and if not, add a platform. And now the game is a lot harder. Now there's obviously a lot we could still do here. There's still a lot of room for improvement in the level generation, and if this were a serious game I'd add a reset button if you get stuck, vary the platform sprites, add a main menu, etc. There also does seem to be a bug here. I'm seeing one jump arc that intersects platforms, which shouldn't happen, so please let me know in the comments if you spot my mistake. But we've covered everything I wanted to in this tutorial, so I'm going to leave it here. I might come back and make some of those improvements next time, or I might start something completely new. That's up to my Patreon supporters. If you'd like to support these videos or vote on what I cover next, you can do that at patreon.com/thoughtquake. I'd also really appreciate it if you hit the like button, spread the word, and subscribe if you haven't already. And as always, thanks for watching.